Hello, I'm Ben Hunter, and I've worked this semester with Jim, Matt, and Albert on the waveform identification project that was put forth by General Dynamics. This semester has been eye-opening to say the least. We have barely scratched the surface of the nuts and bolts of artificial intelligence and neural networks from a programming standpoint, but the research has been abundant. We have spent most of our time digging into types of waveforms and their features, as well as taking online classes on neural networks and deep learning. We have also had the task of learning how to use MATLAB to program our AI. We will all no doubt work during the holiday break, but begin full force next semester programming and making changes to the various parameters of the network with the goal of achieving at least 90% identification accuracy. With the right configurations, we hope this will hold true even when noise begins to be introduced. Lastly, with time permitting, we will add more and more waveforms, hoping to maintain the same level of precision.
Hello, Jim Stewart here from Modulation Maniacs, also known as Team 34. I'm here to discuss the progress that we've made this semester in our senior design lab. Our goal is to use a neural network to detect a useful LTE signal in a noisy environment. While most of this semester was spent researching different types of neural networks, we have accomplished some major milestones. Working with General Dynamics, we've developed a reliable method for transferring and loading large data sets. This was a crucial step as thousands of LTE and noise signals have to be fed into the neural network for training. We've also tested the method on a prototype neural network. We used pristine LTE signals to train the network, and it was able to classify signals with approximately a 94% accuracy rate. These initial results will serve as a baseline for the project going forward. Next semester, we will use the scientific method to systematically improve the performance of the network. We will experimentally determine the optimal network parameters to accomplish our goal. As the signals get noisier and the network becomes more complicated, more processing power is going to be needed. The team has researched commercial GPU farms as a possible solution to this. Once we reach our project goal of classifying noisy signals with an accuracy of greater than 90%, we will introduce additional types of modulated signals. The hope is that the network will be useful as a general purpose signal detector rather than just an LTE detector. This would allow the network to be used on many other projects in the future. Thank you.
Hello, my name is Matt Hasty and I'm a member of the ASU Senior Design Team 34. Together with 3 other students spread across the U.S. and our mentor from General Dynamics, we have refined the focus of our project from training a neural network in MATLAB to recognize waveforms to testing multiple weighting criteria in the training phase to determine the best setup for correctly finding whether signals exist in a low signal-to-noise ratio dataset. Next semester, we will begin our testing and data recording with datasets that contain LTE signals. Once satisfied with these results, we will begin adding more signal types and repeating testing to determine if previous results hold true. Thank you for your time and have a great day.
Hello, I'm Albert Kalustian and I am a part of Team 34 for ASU's Senior Design Project fall 2018 until spring 2019. This past semester we've spent a lot of time learning about machine learning, about neural networks, and how to apply them in detecting signal types amid varying amounts of noise. For our project, we're going to continue trying to discern initially an OFDM signal through a varying amount of noise. And over the course of the semester, we hope to be able to discern signals with about a 90% level of accuracy. And we will use machine learning primarily to do this. So we've learned a lot. We have most of our work ahead of us, though most of this semester we spent conducting research, speaking with Tal Aragaki over at General Dynamics, who is our mentor, and learning a lot about the ways that we can use MATLAB and different forms of machine learning algorithms to produce the results that we want. Over the course of the coming break before next semester, our team is going to spend some time debating the different kinds of neural network architectures that are available to us and what we think is going to work best for us, specifically in trying to balance the performance versus cost and time question. We don't want to spend too much time unnecessarily if we have too complex of a neural network. So it's kind of a question of how do we weigh the different options ahead of us. So we've started talks with that regard, and over time we're going to really solidify these decisions, hopefully before the beginning of next semester. So that's it for what we've completed this semester so far, and we look forward to next. Thank you.